Hey, I'm Liz, and I'm a developer advocate at Evervault.
I'm Liam. I'm one of the engineers working on our new product, Cages.
And today we're going to talk a little bit about attestation. So in the context of secure enclaves, what exactly is attestation?
Attestation is a way of cryptographically proving the integrity of the software that you're talking to within the enclave. So it's particularly important for enclaves because you generally process your most sensitive data within them. So you want evidence of what software is able to touch that data.
That makes sense. So when someone is spinning up a cage, what does the attestation process look like? Like, how does that get kicked off?
So within Cages, we embedded the attestation into the TLS handshake. So that means that an Evervault client talking to a cage isn't capable of sharing data with an unattested enclave, which has some pretty profound implications for people's data security. The way this works is by provisioning intermediate CAs into the cage, which the cage then uses to generate self-signed certificates, which include attestation documents to be consumed by the client.
Okay, cool. So you have basically this authority that says like you're allowed to spin up a certificate, and then once it knows it's there, then it can create the attestation doc. Is that kind of how it works?
So the cage can always create an attestation doc,
Okay.
but by provisioning a CA from our central authority, people can trust that this is a cage that has been both attested by us and by their client.
Okay, cool. So how long is that doc good for? Does it ever expire, or can you reuse it?
Yeah, so attestation docs have a lifetime currently of 3 hours. So that means that within a cage, we essentially refresh the certificate that's served back to the customer containing an attestation doc every 3 hours, give or take, because it's handled lazily. But in certain cases where a customer provides a nonce in the request to the cage, that cert will be generated fresh for every single request. Supposing we have some cage and we have our provisioning service, which has access to a database that contains all of the expected attestation measures for the cages running on Evervault. So cages run an EC2 instance that has a host process called the control plane. And the control plane is deployed by Evervault and managed by Evervault. So we consider it a trusted party within the handshake. So when a cage gets deployed, the control plane uses an MTLS client cert to authenticate with the provisioner. And it basically sends a request that just contains the UUIDs for that cage over that MTLS connection. And the provisioner then validates that those UUIDs are as expected and generates a signed token, a JWT. And the JWT contains the UUIDs to identify the cage and the IP that the JWT was issued for. So that gets sent into the cage, which then produces an attestation document. So that attestation document contains that JWT. So we've now essentially bound the trusted party of the control plane into the enclave. So we now, using this attestation document, can prove the integrity of both the cage and that it came from the correct instance. So then the second part of the handshake is that the cage sends a request over a TLS connection via the control plane, which contains that attestation document with the JWT. So within the provisioner now, we're able to correlate the two requests, verify the integrity of the cage, and check that the PCORs from this attestation doc match the PCORs that are in our database. So that means that we know that we're speaking to the correct version of the cage as well. Once all of that checks out, the provisioner then uses our root CA to generate an intermediate CA. So that intermediate CA will be served back to the cage, and the cage is going to use that to generate its own leaf cert every 3 hours or for each request with a nonce. That intermediate CA is only capable of signing and issuing certs for that specific cage's hostname. And the provisioner's public key for our root CA is exposed to all the Evervault clients. So Evervault clients can then take the CA signed using this intermediate and trust them because the root of trust goes back to the public key that they know of.
Should we talk about the attestation process now?
Yeah, from a client's perspective, it becomes really simple once this complex stuff is understood. So from the perspective of an Evervault client, they run their server, which includes the Evervault SDK. And when they initialize the Evervault SDK, all they need to do, depending on the language, is enable a cage client. And then they just pass in an object that has the cage's name and the PCORs that they expect to see back from the cage. So once they've done that, we install our root CA for this cage. And then when they make HTTP requests, we'll intercept the TLS handshake that's going to a cage, and we'll put this step in the middle, where when we receive the cert that contains an attestation document, the Evervault client will essentially add an additional validation step to the TLS handshake. So typically you would just validate that you trust this cert, whereas for an Evervault client, we also want to know that we trust this attestation document because the TLS handshake will check out anyway. So once we receive that cert back, we'll parse out the attestation document, we'll validate things like the AWS signature over that attestation document, but we'll also check that these PCORs line up. So that client can know for certain that it's only speaking to the expected version of their software.
Is there anything else that you think is helpful for developers to know about the attestation process as they're getting started with cages?
Well, I touched on it earlier, but I think tying the TLS handshake and attestation together is pretty impactful. And then when you additionally layer in the field level encryption, customers that build their system to encrypt in many places, say in the browser using our other product Relay, if they only trust their decrypts to happen within attested enclaves, they can essentially de-scope their entire product down to knowing that one specific service with cryptographic proof is the one place where they'll decrypt their data.
Yeah, that's a great point, and it's so powerful because I think a big mistake where a lot of people kind of go wrong is because they aren't sure where encryption actually fits into their architecture. And so, as you mentioned, by using it at the field level, you can just ensure that it's protected no matter where it is in your system, right?
Mm-hmm. Yeah, and you can just narrow down that scope of what happens within the enclave.
Hey, thanks so much for checking out this video on attestation. Be sure to like it and subscribe to our channel for more Evervault updates. You can also watch this video next, which is a walkthrough of how cages work. See you next time.